Okay, one of the important applications of image processing is in satellite communication. Whenever communication comes into the picture, no communication without any noise. Communication means there is a noise. Then obviously, whenever the image is transmitting from one side to another side, it gets affected by the noise. It gets affected by many types of noise, but let us now restrict it to the salt and pepper noise and Gaussian noise. Okay, then how can we remove those noise from the images, and how can we remove those, and how can we enhance the picture by removing those noise? We will see now. Since we do not have the noisy image right now, what we can do is we can add noise to the image. To check the filtering, we will add the noise to the image. To add the noise to the image, the command is imnoise. If imnoise command, it is going to add the noise to your image, and you can add whichever the type of image you want to add, you can add there. Here, if you want to add, here you need salt and pepper noise, you have to mention the keyword salt and pepper. If you want to add the Gaussian noise, you have to mention the word Gaussian. Then you have to mention the speckle noise, you can add the keyword speckle. So now go to the Skylab. Here help browser is there now. Click over there, and here you just type imnoise. Noise, and see here you can see which are all the types of noise you can add and which are all the parameters, how it's gonna work, all those things you can see here. Now I will just show you how to add the noise to the image and how does it look like. Okay, now let me read the image. I will type the program in console window only. First let me read the image. Read. The image is stored in G drive. So G in the folder SDP with the name, I am reading the color image JPG. The name of the image is wedge. Okay, what is wrong here? Okay, I'm sorry. Now the image is red. Next, I want to convert it to grayscale. RGB to gray. Now I want to add noise to this image. That is C is equal to imnoise. Add noise to image B. And what type of noise you want to add? Let us first add salt and pepper noise. Let us just add like this, and we will see what happens. Then show C. Okay, now see here. Now you can see the dots now. These dots are called salt and pepper, means black and white noise. So it is salt and pepper noise. Now see here in the same command, see here after this salt and pepper, I will write 0.3. Means it is the density of the image. Now see here, the noise is very, very higher. Usually the default density is 0.05, which is very, very lesser. Now I have increased it to a very larger extent, 0.3. If the noise is this much, then even after filtering, we won't get the proper image. It won't be this high usually. So we will stick back to the default density. Next, we will see Gaussian noise, and we will see how does it look like. Okay. Now see here, again the quality is degraded. By default, it is going to take its mean value and variance value. If you want to change, you can change over there. Okay. Next, we will see how to remove these noises. Now we have seen how to add the noises to the image. Next, we will see how to remove the noise from the image. For that, I will go to script and I will write the program. Pick new script. Okay, now we will see how to remove the noise. See, as we have discussed, first I am reading the image, converting it to binary scale, then I am adding the noise, salt and pepper noise. Then here, the type of filter I'm using is just, it's called mask. I'm using 3 cross 3 ones. 3 cross 3 matrix with all the values 1 and those values divided by 16. For this, you need to know the theory behind this, but right now it's not required. Let it be. So I'm dividing that value by 16. So this is being used as a filter. Next, what I'm doing is, I will next the recovered image D is equal to IM filter. So noise image is C comma and my filter is MF. So B, C, D. B is the original image, C is the noisy image, D is the recovered image. Let me save this with the name program noise and save it, and let me execute this. Okay. See here, this is the original image, this is the noisy image, this is the image we have obtained after filtering the noise. Now, if you vary this denominator, instead of 16, if you keep some other value like 10, 3, 2, the recovery is going to change. It definitely, its value is going to change. Now, let us check that. Instead of 16, I'll make it 3 and I'll run the program. We will see how does it look. Okay, now see here. It is changed. So by varying this filter coefficient, the recovery of the image can be improved. Okay, now see here, it is better compared to the earlier two cases, right? This is about noise filtering. Here it's actually a wide topic. You need to know a little theory behind this, otherwise it becomes difficult. So I'll leave it as an exercise. You just try to learn it yourself. Okay. The next topic is edge detection. How can we detect the edges in an image? We will see, and we will wind our session after that.